Next, we create the sensor for detecting the arrival of material on the conveyor belt. Choose Collision Sensor and select the outer surface of the sensor as the object. Set the collision shape to line. To ensure it detects the material's arrival, we need to reverse the coordinate system's direction. Select the arrow and double-click with the left mouse button to reverse the direction towards the conveyor belt. Name the sensor CS7. And click OK to complete the creation of the collision sensor. Next, we'll control the position and speed of the previously sliding joints and hinged joints. Choose the position control. Select the telescopic rod and set its movement speed to 200 mm per minute. Click Apply. Select the slider and set its speed to 100 mm per second. Click Apply. For the rotating rod, set its movement speed to 100 degrees per second. Click Apply to confirm. Select the turntable's hinge joint and set the speed to 200 degrees per second. Click OK. At this point, we need to adjust the turntable's vector direction since it will rotate clockwise. To ensure this, reverse the vector direction now so that when we input positive values, it will rotate clockwise. Click OK. Finally, we will create the conveyor belt. Select the transmission surface under the position control. Choose the upper surface of the conveyor belt, specify its vector pointing forward. And click OK to complete the creation of the conveyor belt. Next, we'll create the gripper and the tool hand. From the Mechanical, click on the More drop-down menu and select Gripper under Custom Behavior. For the gripper's base body, select the telescopic rod. For the detection area, choose the center point, radius, and height. Now, we define the orientation of the detection area, which refers to the size and position of the object that the gripper will hold. Set the object's height to 14 mm and the radius to 10 mm. Proceed to specify the orientation. Click the CSYC dialog. In the options, select Point dialog to set the origin of the coordinate system. Click between two points to specify the origin. Choose a point on the right side of the gripper tool and another on the left side of the gripper. The system will calculate the midpoint between the two, which will serve as the origin of the coordinate system. As shown, click OK. At this point, the direction of the object being held by the gripper is incorrect, so we need to rotate it. Select the control point between the coordinate systems, click with the left mouse button, and input a rotation angle of -90 degrees. Press Enter to preview the position and size of the gripped object, ensuring it is correct. Next, configure the gripper's fingers. In the fingers, click Add New Finger. select the right gripping block and specify its vector to the left. Add another finger. Select the left gripping block and specify its vector to the right. Lastly, set the initial position, max position, and speed of the gripper to 20 mm per second. Once done, click OK. With this, we have completed the creation of all the basic attributes for this motion setup. Next, we will simulate the operation process of this production line through a simulation sequence. Select the sequence editor from in the software. Hold the left mouse button. Drag it to the bottom of the working interface, then release it to place the editor at the bottom. In the blank area of the sequence editor, right-click, Add Operation, naming it Conveyor On. For the conveyor on sequence, choose the transmission surface as the physics object. Set the runtime parameter for its parallel speed to 100 mm per second. The condition to trigger the movement is the sensor CS6. Where the conveyor will start moving when no material signal is detected. Click OK to complete the conveyor on setting. Next, we will similarly create a conveyor stop command. For the conveyor stop command, select the transmission surface again as the physics object and set the speed to 0. The conveyor stop condition is linked to the material arrival sensor CS7. When its signal is, the conveyor will stop. Another condition for stopping the conveyor is when all the material slots on the turntable are full, at which point the conveyor should also stop. Here, we add a parameter. Select the parallel condition with the option OR, meaning that when material sensor CS6 detects material and its signal is true, the conveyor will stop. Click OK to complete the conveyor setup.